So, I want you to picture something for a second.
Yeah.
It's the year 1420.
Okay, going way back.
Yeah, way back. And it takes this young guy, 7 whole years of just silently sweeping the floor of this blistering hot, soot-stained workshop to learn the absolute basics of blowing glass.
Right, 7 years just to get the basics.
Exactly. Fast forward to today, and you've got a 23-year-old sitting in a climate-controlled apartment. They pull up an AI assistant, and they just build this massive, globally scalable software architecture in like 20 minutes.
It's a completely different universe.
It really is. I mean, we've basically annihilated the time it takes to execute a task.
Yeah.
And the gap between those two realities feels totally insurmountable.
Oh, absolutely.
But, and this is the crazy part, according to this brilliant new piece of writing we're diving into
Right.
today, our modern obsession with, shrinking the time it takes to produce things.
Right, the speed aspect.
Yeah, that speed might actually be destroying our ability to know what we're doing in the first place.
Which is such a profound paradox, honestly. I mean, we naturally assume that when you rewrite the tools of production, you just rewrite the fundamental laws of human learning alongside it.
Because the tools are faster, so we should be faster, right?
Exactly. We see the blinding speed of modern technology, and we just assume, well, the cognitive barriers of the past simply don't apply anymore.
So today's mission is pulling apart that exact assumption. We are exploring how we actually learn the critical skills that, frankly, simply cannot be taught through a manual or, a quick YouTube tutorial.
Because there's so much that escapes those formats.
Totally. And we're grounding this deep dive in a really fascinating long-form essay. It was published just today, actually, June 3, 2026, in Tech Reader magazine.
Ah, yes, part of their Quiet Revolutions series.
Right. It's called The Transmission, and it's written by Aaron Rose.
And what Aaron Rose is doing here is so smart. He's interrogating the actual mechanics of the old master-apprentice system.
Like looking past the historical vibe of it?
Yeah, exactly. Looking past the aesthetics to isolate the actual cognitive function that system served. And he builds this incredibly compelling argument for why that specific mechanism matters today, like more than at any point in the last 100 years.
Okay, let's unpack this, because, taking a medieval glassmaker and using them as a diagnostic tool for modern software development is a massive conceptual leap.
It is a huge leap, but that tension is precisely where the essay starts. The question is, why hasn't the blinding speed of a large language model or a modern development environment completely erased the need for this ancient, incredibly slow method of knowledge transfer?
Right.
So to explore that, Rose introduces this historical baseline through a young apprentice named Thomas.
Right, so Thomas walks into this 15th century European glassmaker's workshop. And the defining characteristic of Thomas, as the source points out, is his total lack of utility.
He is basically useless day one.
Totally useless. He brings absolutely no skills. He doesn't know how to handle a blowpipe. He doesn't know the temperature at which silica, stops being ordinary sand and transforms into molten glass.
He has zero context.
Exactly. He just has the master's permission to be physically present in the room.
And for those first few years, his physical presence is tied to entirely menial labor. I mean, he sweeps the stone floor, he carries wood.
Sweeping and fetching.
Right. He tends the furnace to keep the heat consistent, but he does not touch the glass.
See, okay, sweeping floors for 7 years sounds like an absurd waste of human capital. I mean, from a purely historical and economic perspective, I kind of have to push back on this.
I get that. It sounds crazy to us now.
Because the standard guild apprenticeship was famously brutal, right? Wasn't the entire guild structure fundamentally just an economic cartel?
Oh, for sure.
Like, they artificially restricted the labor supply to eliminate competition to keep the price of glassware astronomical? Right. So dressing that up as this noble educational journey feels a bit, romanticized.
Well, it's a great point, and the author actually leans into that economic reality. The guild system absolutely functioned as a monopoly. It utilized intense gatekeeping, and it excluded huge swaths of the population by design.
Right, it was very exclusionary.
Very much so. But reducing that 7-year timeline strictly to market manipulation misses the mechanical reality of the work itself.
How so?
Well, withholding a secret recipe doesn't require 7 years of indentured servitude. You can just hide a piece of paper for that.
Right, that's true.
That extended timeline was a practical solution to a genuinely hard problem. They were attempting to transmit a category of knowledge that just fiercely resisted being written down on paper.
Because the Kempt formulas only get you so far, right? Like you could hand someone a piece of parchment that says, you need to mix silica with a specific flux.
Precisely. Silica, which is basically just sand, melts at a wildly high temperature, like around 3,000 degrees Fahrenheit.
Which is insanely hot.
Yeah, so you have to add a flux, like potash or soda ash, to lower that melting point so the material becomes workable in a standard furnace. But the ratio of those ingredients radically changes how the glass behaves when it hits the ambient air.
Okay, I see.
You can write down a basic ratio. What you cannot write down is the precise, intuitive judgment required to say, look at the color of the heat radiating off a gather of glass and know exactly when it is ready to be shaped.
Ah, right.
Mhm.
So if you can't document the process in a manual and you can't give a lecture on it, it forces this larger question about what is actually happening in that workshop.
Exactly.
Like if it's not just a set of deterministic instructions, how does the brain actually acquire that skill?
And the essay leans on the work of Michael Polanyi to explain this. He was a 20th century philosopher who categorized this phenomenon as tacit knowledge.
Tacit knowledge.
Yeah. He summarized the entire concept in this brilliantly precise formulation. He said, "We know more than we can tell."
We know more than we can tell.
Uh-huh.
That's really profound.
It perfectly captures it, doesn't it?
Yeah. And if you think about it, think about your own job or your own daily routine. Just think about that one complex task you do purely on autopilot.
We all have one.
Right. And if a new hire shadowed you and asked, hey, how did you know to do that?
Yeah.
Your only honest answer would be a shrug and I just know.
Yep. That is Polanyi's tacit knowledge in action.
So how does the text illustrate this? Because it sounds a bit abstract.
The text provides this rapid-fire sequence of examples to crystallize how this manifests across different disciplines. Like, consider a master stonemason.
Okay.
They can look at a rough block of limestone, hold a chisel at a highly specific angle, and strike it with exact force, knowing inherently how the internal fault lines of that specific rock will give way.
Oh, wow. Yeah. Or like the jazz musician operating on stage.
Exactly, the jazz musician.
They're anticipating and reacting to the bass player's shifting tempo, deciding the next note in their solo before their conscious mind has even, like, registered the chord change.
Yes. Or think about the experienced physician who walks into an examination room and instantly senses that a patient is spiraling into sepsis.
Just from a glance.
Right. They process the pallor of the skin, the microexpressions, the subtle changes in respiration, and they formulate a life-saving clinical intuition minutes before the blood work or the digital charts confirm the diagnosis.
It's almost like a sixth sense.
Yeah.
And the text also mentions the veteran engineer walking the floor of a manufacturing plant, right?
Oh, yeah. The vibration example.
Yeah, they hear the ambient roar of the machinery and feel a microscopic vibration in the floorboards that tells them, hey, a turbine is operating slightly out of phase long before the digital sensors trigger an alert on the dashboard.
And Polanyi's overarching point, which Aaron Rose emphasizes really heavily, is that none of this relies on magic or mystical superpowers.
It's not supernatural.
No, it is a biological process.
You know, it maps perfectly onto the experience of cooking without a recipe.
Oh, that's a great comparison. Like, if you've been making the same complex pasta sauce for a decade, you stop measuring the salt with a spoon, you smell the reductions simmering on the stove, you factor in the acidity of the particular tomatoes you bought that week, and your brain just outputs the instruction, needs a heavier pinch of salt.
And you could never write that in a cookbook.
Right, because the instruction is entirely dependent on real-time sensory feedback. But wait, we are in 2026. If I want to learn to cook a complex sauce, can I just YouTube the technique or read a highly detailed digital manual?
Well, what's fascinating here is why the modern shortcuts we've built completely fail to transmit this specific type of expertise.
They fail.
Yeah, they really do. I mean, we live in an era of hyper-detailed YouTube tutorials, comprehensive masterclasses, and searchable digital wikis. And those tools are incredibly effective for teaching procedural knowledge.
Right, the step-by-step stuff.
Exactly. They can teach you the sequential steps. But tacit knowledge, as the essay defines it, is the residue of thousands of hours of practice, failure, and correction. Ah, the failure part is key. Because a video tutorial only shows you the happy path, right?
Yes, the polished final version.
It shows you the flawless execution. So it kind of deprives you of the neurological feedback loop of seeing something go slightly wrong and watching an expert course correct in real time.
Precisely. And that's why the apprenticeship was essentially this immersive neurological environment. The entire goal was to slowly, fundamentally recalibrate the apprentice's nervous system through sheer proximity to an expert.
Just by being in the room.
By being in the room. You watch someone who already knows how to see see, and through ambient absorption, your brain begins to recognize those same patterns until you develop the capacity to see it yourself.
So you're internalizing their underlying standard of quality rather than just copying their physical movement.
Yes, exactly. If you try to compress a 7-year timeline into like a 6-week intensive boot camp, the transmission of that standard breaks down.
You just get a mimic.
Right, you graduate a student who knows the mechanical steps, but who freezes in absolute panic the moment the environment throws a variable at them that wasn't covered in the syllabus.
Which pulls us directly out of the 15th century and into the absolute bleeding edge of the 2026 tech sector.
Yes, this is where the essay makes that jump.
And it uses this historical baseline to diagnose a massive shift happening right now. And it illustrates this through two software developers, Ethan and Hank.
This is where Aaron Rose successfully bridges that theoretical gap. He places the glassmaker's cognitive model directly against our current technological reality.
So let's look at Ethan's workflow first. Ethan is 23 years old, highly intelligent, and utilizing the most advanced AI coding tools available in 2026.
Okay. To be clear, the author is careful not to dismiss Ethan as a fraud.
No, not at all. The tools are remarkably powerful. Ethan is engaging in what the tech community now calls vibe coding.
Right, vibe coding. For those unfamiliar with the mechanics of that term, it represents a major paradigm shift.
Yeah, it's wild.
Instead of writing rigid, deterministic logic loops line by line, developers like Ethan build software through conversational iteration with an AI system.
So they're not typing syntax, really.
Exactly. They steer the probabilistic output of a large language model by continually tweaking their natural language prompts. They are essentially following the feeling or the intuition of the user interface, massaging the application until it behaves correctly.
It's much closer to sculpting clay than traditional typing.
That's a great way to put it.
I mean, Ethan can describe a complex feature in plain language. Watch the AI scaffold the entire architecture, refine the output, and push it to production. He's effectively compressing what used to be 3 days of grueling senior-level programming into 20 minutes of prompt engineering.
And the author concedes this is a staggering leap in productivity. Exploratory intelligence is being rewarded at an unprecedented scale.
Here's where it gets really interesting. If Ethan is churning out working prototypes in 20 minutes and iterating through 10 different design approaches in a single afternoon, the logical conclusion is that veteran developers should be completely obsolete.
They should be extinct.
Right, the market just shouldn't need them. Which introduces Hank. Hank has been writing production software for 22 years.
And under the standard Silicon Valley narrative, Hank should be the dinosaur. He should be the legacy employee clinging to outdated syntax, actively threatened by the AI tools Ethan is wielding.
But Hank isn't threatened at all. He uses the exact same AI assistance Ethan does. The difference lies in his fluency.
Right, Hank uses the models with the deep skepticism of someone who understands the underlying technology well enough to spot when it is hallucinating a variable.
Or when it's making a subtle, dangerous assumption about the database structure. So if the AI is mathematically capable of catching syntax errors and ensuring the code compiles, what is Hank actually doing during their code reviews? He must be searching for a layer of logic that the AI fundamentally lacks the context to understand.
He is evaluating the macro architecture. When Hank sits down to review Ethan's AI-generated code, he bypasses the micrologic entirely.
He doesn't care about the small stuff.
No, he doesn't ask if the authentication function works. The automated tests already proved it works. Instead, Hank probes the structural integrity over time. He looks at the abstraction and asks, when our client changes their data privacy requirements in 6 months, will this architecture snap in half?
Oh, man. So he is interrogating the hidden cost of the speed.
Yes.
Hank is asking if the structure makes sense for the next 3 features coming down the pipeline that Ethan hasn't even looked at yet.
Because Hank's mind contains an invisible graveyard of dead startups, failed deployments, and catastrophic technical debt.
Oof, that's heavy.
It is, and he is projecting those past failures onto Ethan's pristine, newly generated code. And the essay notes that Ethan initially finds this process agonizing.
I bet. From his perspective, the feature shipped. The user interface looks great. Hank's hypothetical, long-term architectural anxieties probably feel like an arbitrary roadblock.
Because Ethan thinks the job is producing working code. Hank knows the job is building a system that survives contact with reality.
Wow, yes.
Yeah.
And because Ethan is forced to sit through these agonizing code reviews week after week, something remarkable happens.
The transmission occurs.
After 2 years of proximity to Hank, Ethan's approach mutates. He starts anticipating Hank's objections before he even submits the code.
He develops what Aaron Rose perfectly describes as peripheral vision.
The ability to see the consequence lurking just around the corner.
Exactly. He learns to spot the hidden assumption buried 3 layers deep in a third-party library that will inevitably cause a massive server outage during a holiday traffic spike, like a year down the line.
So Ethan essentially builds a mental simulation of Hank's judgment in his own head.
He really does.
And Ethan didn't acquire that predictive capacity by downloading a software patch. He didn't read a manual on peripheral vision. He acquired it the exact same way he would have acquired it in 1420.
He is Thomas. The underlying mechanism is completely identical.
The physical environment has traded a roaring furnace for a glowing monitor. But the transmission of tacit knowledge remains totally unchanged.
Thomas sweeping the stone floor is functionally equivalent to Ethan quietly enduring Hank's architectural critiques.
It's the exact same process.
The blowpipe and the large language model only alter one variable.
They alter the cost of production.
Right.
They drastically reduce the friction required to make a tangible object or a piece of software.
But they do absolutely nothing to accelerate the development of human judgment.
Man, that is so crucial.
If we connect this to the bigger picture, this leads us to the most vital distinction in the entire essay. Rose writes, and this is a quote, "The apprentice's hands could be trained in months. The apprentice's eye took years. The hands executed. The eye decided."
The hands executed, the eye decided.
It's a great line.
It really is. A modern AI coding assistant is basically the ultimate set of hands. I mean, you can train a 23-year-old to operate those hands with terrifying velocity in a matter of weeks.
They can produce massive quantities of output.
But the eye that cultivated judgment required to know what actually needs to be built and whether the thing you just produced actually possesses underlying quality that cannot be downloaded.
The eye requires calendar time. It requires the slow biological recalibration of a human nervous system through exposure to an established standard.
Which poses a critical question for you listening to this deep dive right now. Regardless of your industry, where are you getting your proximity?
That's the real question.
Because the source is incredibly clear that acquiring this eye does not require you to sign a literal medieval contract.
Right. Proximity scales to any environment.
It happens in high-pressure newsrooms, where a junior reporter absorbs the invisible editorial standards of a veteran editor dismantling their pitch.
Or in commercial kitchens.
Yeah, where a line cook learns the rhythm of a dinner rush by syncing their movements to the sous chef. It happens in pharmaceutical labs and recording studios.
It simply demands 3 ingredients. An environment containing genuine expertise, an attentive learner willing to submit to the process, and a significant investment of time.
And that time investment is where our modern technological moment lays a really dangerous psychological trap.
The speed trap.
The speed trap, exactly.
Because modern tools make high-velocity output wildly intoxicating. They provide an immediate, powerful dopamine hit.
Oh, for sure.
A junior employee can use generative AI to produce a 50-page market analysis or a complex application in an afternoon. And the immediate feedback is, I made a thing, and the thing looks highly professional.
Because the sheer volume of output is so high, it tricks the creator into believing they have achieved mastery.
The AI simulates the competence of the hands so perfectly, the user forgets they haven't developed the eye.
And that creates a massive incentive to just bypass the unglamorous, frequently boring process of ambient observation.
The shortcut becomes indistinguishable from the destination, but, the 15th century workshop offered Thomas no shortcuts because none existed.
He had to do the time.
He was forced to endure the proximity, he was forced to wait, and once that waiting forged his capacity to see what the master saw, that judgment became an innate biological asset that could never be taken from him.
The sweeping, the staring, the agonizing code reviews the tasks that look like waiting or friction or roadblocks that was actually the work itself.
It was the only conduit through which the transmission could occur. True mastery demands an environment of friction.
So what does this all mean? It means that as we surround ourselves with tools explicitly designed to eliminate friction and execute tasks in milliseconds, the slow, deliberate cultivation of judgment becomes the single most valuable asset in the modern economy.
It's the ultimate differentiator.
Your hands can move at the speed of a microchip, but your eye is still bound to the speed of human experience.
It is a really sobering realization regarding the limits of our technology. And, it sets up a fascinating philosophical dilemma, which Aaron Rose actively teases at the conclusion of the magazine piece for his next installment in the series.
Oh, right, the teaser for the next issue. It was titled, Judgment as the last human moat.
Yeah. The historical trajectory is undeniable here. Every cognitive tool we have ever invented has eventually automated a process that previously demanded intense human effort.
Like we mechanized physical labor with the steam engine,
We mechanized arithmetic with the calculator.
and we're currently mechanizing complex syntax and deterministic logic with large language models. The tools perpetually consume the execution layer.
The hands are fully automated.
Right.
But judgment, the capacity to evaluate context, to decide what holds systemic value, and to determine what ought to be built in the first place, has successfully resisted automation.
It remains a strictly biological phenomenon.
Exactly. So the lingering question we must confront as AI systems grow increasingly sophisticated is this: is human judgment truly an impenetrable moat?
Or will our capacity to decide what is good, our variability to act as the eye, eventually be mapped, replicated, and automated away alongside the hands?
It's a huge question.
That is a staggering question to carry forward. Will the AI eventually absorb the eye, or will the capacity to care about the outcome remain exclusively ours? We will definitely be diving into that next essay the moment it drops.
Can't wait for that one.
Thank you for joining us on this exploration today. As you log back into your workflow or step into your next meeting, try to look past the blinding speed of the tools in front of you. Seek out proximity to the judgment you want to acquire. Protect the slow development of your own eye, and remember, sometimes the sweeping is the most important part of the job.